So go to page 34 here, and we'll just quickly go over this. I'll go a little faster than I normally do, okay? Potato chips come in a mean weight of 250 and a standard deviation of 5, so that's important, right? The weights in the bags follow a normal distribution. So later on, we're going to figure out whether or not the data is normally distributed. But if that, what's the rule if this is true? Which rule should we be thinking of when it's normally distributed? What are the three numbers? 68, 95, 99.7. It's called the empirical rule. Trust me, you're going to hear that again if you take stats. If you take nursing, anything in the medical field, they're going to make you take statistics because they want you to be able to look at data and analyze it, not just blindly trust what experts are telling you. They want you to look at it and see, like, what else is data telling me. Okay, so here we go. Sketch a normal curve, percentages, blah, 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 right? So we're going to find the middle. We're going to go to the top here somewhere, and I just go from there, curve down like this. Curve down like this. Don't make it go too close, but it never touches. And then you just slice it up. It's always 100%, right? So this would be 1, 2, 3. And then you do the same thing to the right. 1, 2, 3. And so here we have 250. And this is grams. Okay, 250, 255, 260, 265. This is 245, 240, 235. Okay. So we've got that. Percentages. You should have all of this on your study sheets. There we go. And so I just memorized one side, 34, 13.5, 2.35, and this is 0.15, right? Everything, the tail of the curve is 0.15. And then just copy that. Oh, two 13.5s, that can't be. 2.35%, 0.15%. Okay. So after today, you should, I'm going to give you a bunch of ACs that kind of make you practice these things here that we're talking about. It also, I want the z-scores. Z-scores, okay? So a z at the very, if you have a z-score of 0, that means that you're right at the mean. Okay, if you have a z-score of 1, 2, 3, then you're above the mean. If it's negative, you are below the mean. And keep in mind that they're technically values all along this x-axis. Anything goes, but these are the ones we focus on. Okay. Use technology to answer the following. What does it say? Use the graph? Nope. It says use technology. So this is just going to be for reference purposes. Okay. Calculate the probability percentage of bags weighing between this and this. It wants probability, so we got to use normal CDF and then just type that in. 232, 273, and our mean we know is 250. Standard deviation is 5. What is that? Do I want to type this in? Sure. There we go. That's 0.9998 and then something. We multiply that by 100, and that would be 99.98% of bags. Okay. Does that make sense? That's almost all bags, isn't it? So let's go look. 232 is somewhere over here. And 273 is somewhere way over here. So it is almost the entire curve. So it makes sense that it's almost 100%. Okay. So that's why I want that graph there. Calculate the percentage of bags that are heavier than 257. Percentage is always normal CDF. Okay? So we go normal CDF heavier. So 257 is the low limit. So what would you put under the upper? Give me a number. 1 million, 2 million, 3 million. Mr. Erickson, what about 10,000? Would that work? Yes. Anything that is very extreme, because 257 is somewhere over here. So anything that's way over to the right. So we're going to go 1 million because it just go big or go home, right? I will say this, pick a large number, okay, for this one. And so we're going to figure that out. Mm, 257, 1 million. There we go. That's 0.080 something. Multiply that by 100. So if you don't want to risk it, just go ahead and do that on your calculator, 0.08%. That's what I got. And then double check, 2.57 is somewhere over here. And it's not all of 13.5, right? It's just partial. So you're slicing from here onwards, so 8.08% of bags. Okay, I want to pause here for a bit. Do you know what you're doing? That's always my concern, right? Do you know what you're doing here, or are you just typing in blindly? You found out the likelihood, the chance of a bag being heavier than 257 is 8.08. The expected number of, not number of bags, but percentage of bags that would be heavier is this, right? So just so you understand, that's what you're doing here. Calculate the percentage of bags weighing less than 243.5. So here, don't put 243 in here because that's not the low limit. That's actually the upper limit. So we know everything except for our lower limit. So we're just going to go negative 1 million. Oops. You would get the same answer if it's a million or 10,000. Probably get the same answer. I'll give you this promise. If yours is slightly off because you went negative 10,000 and I went negative a million, I'm not going to take any marks off because it just has to be very extreme on this side, okay? So you get 0.0968 and something, you multiply that by 100, that's 9.68% of bags are expected to weigh less than that. So maybe I should highlight, this is the heavier part, this is the weigh less part, okay? The company disposes of any bags weighing less than 239 grams. Any bags weighing more than, and any bags weighing more than 262 grams. What percentage of bags would the company dispose of? Okay, you got to pay attention to this one, okay? I don't know how you did it. If you looked at my key, you're probably like, I sort of get it. But this is what's happening. Let's make this sketch here if you don't have it. 239 is somewhere over here. This is the 239 mark. I just base it on my nice graph up there. So anything less than, right? This is going to be disposed of. Anything that's to the left of 239, they're disposing them. They're probably like recycling them. I don't know. Put them back in the conveyor belt. And we're also told that anything in the 262 and higher, right? Remove. So we want to know what percentage of bags would that amount to, okay? So you've got a choice to make. This is how I like to solve these ones. I will find percentage of good bags. How would I do that? Normal CDF. Let's see if this makes sense to you. I will go from 239 to 262, 250, and 5. Would that make sense that these are the good ones? You with me? I'm saying normal CDF, tell me the percentage of bags that are in here. These are good. Okay. I will find that. And what will I do with that number? How can I possibly get these tails? The whole curve is 100%, correct? I'm going to find this, subtract that from 100%, and then I'm left with those tails. That's, for me, the easiest way to do one of these. So this is called indirect reasoning. You're finding it a different way, but it's just as effective. So this is what. Let's figure this out. Second. So 239 to 262, 250, 5. You have to read carefully, right? I could have asked you what percentage of the question could have asked, hey, if this is true, how many would be kept? Like what percentage would be kept? This is actually your final answer, okay? But this is, in this case, it's not our final answer. So I'm just going to keep all of it. So percentage of bags removed or discarded would be 1 minus 0.9778 and something. I don't go 100% because I haven't turned my answer into a percentage yet, so I just keep it at 1. So I'm just going to go 1 minus previous answer, and there it is, 0.0221, and then some. I multiply this by 100, 2.21% of bags discarded. Okay. Let's make a note here. Sorry, I'm going to move this up because I know you're probably squinting there. What's happening? This is total area under curve. Okay. This is good bags. So I go total area minus the good ones. I'm left with the percentage that is removed. Whew. Is there another way of doing this? I know some of you are looking and you're like, I would have done it a different way. And the answer is probably yes, you are right. You could have done 2 normal CDFs and added that up, and I bet you and me get the same answer. Maybe off by a little bit, but you're not going to lose marks if you show me your work. Okay? So much work for one question. I will have to say that there's a lot of concepts here. Right? These ones are good, so I want to highlight that. Okay. This is actually the good ones. Right? And so we find it, we subtract it from 1, and then we're left with the tails. Okay. We're good? Very important concept. These ones are worth 2 marks. So if you see a 2 marker, you're like, oh, okay, right? Like it's going to be more than just one normal CDF and away you go. It's going to be more than just that. Okay. Let's keep going. 35. I think here's where I throw in some curveballs with z-scores. And I'm not a German professor trying to say this scores. Okay, z-scores in statistics actually mean something else. Okay, if the company produces 5,400 bags per day, how many bags would be removed from the production line? Well, uh, number of bags removed. This is how I'm going to solve that. I already know from the previous page that it's 2.21%. So I will use that answer like this, and I will multiply it by 5,400 bags. I got this from I, right? So if it's actual number of bags, you take the percentage, turn that into a decimal, multiply it by the number of bags that are in question. Oops. And here you're going to have to round. 119.34. So write down the exact number. That is approximately 119 or 120 bags. Just give me one of them on a test or EC. Just round it to a whole number and we're good. What percent of bags have a weight with a z-score between negative 0.6 and 134? What do we know if it says z-score? What do we know about the mean and what do we know about the standard deviation? What is the mean for a z-score? 0. Okay. Hey, the mean for a z-score is 0. Maybe that helps you remember. The standard deviation is 1. Automatically, I don't have to tell you that because a lot of students are stuck with this one. It's like, well, I don't have enough information. Yes, you do. Okay. So percentage of bags means you're going to use normal CDF. By the way, it's not always going to be normal CDF, but we're kind of stuck for now. We're just using that. So you go low limit, high limit, upper limit, and then 0, 1. Let's see what we get. So negative 0.6, 1.34, 0, 1. Bingo. That's your percentage. Well, not yet. This is as a decimal, right? Multiply that by 100. That's 63.56% of bags. That would represent that many bags, percentage-wise. Okay. So z-score gives you that many. Well, hold on. So does this answer make sense? Think about it this way. Z-score of -1 to +1, that would be 34 and 34. That's 68%. We're not quite going to -1, but we're going past 1 to the right. So it is being in the 63.5 is actually is reasonable, right? So always ask yourself, does that make sense? I know I'm over explaining for some of you. Some of you is like, just leave me alone, I got it. But it's not always an easy concept, right? Calculate the actual weights that correspond to each z-score above. Would the percentage of bags between these be the same? And the answer is yes. Okay, so let's do this. The z-score of -0.6, right? You want the actual weight. You got to use this formula. Let me see if I remember here. I need a study sheet. Is it standard deviation times z plus mean? Okay. Phew, right? So for a z-score of negative 0.6, we would go like this. A standard deviation for this set is 5, right? The z-score is negative 0.6. My mean is 250. Okay, so you just have to type this into your calculator basically, but I will do this in steps. So 0.6, so 5 times negative 0.6, that's negative 3. And you go plus 250. So it's this would be 247 grams. Okay, not x bar, sorry, just x. So a z-score of negative 0.6 would relate to this. It's the same thing as saying a bag weighing 247 in this case. If the z-score is 1.34, you do the same thing again. Standard deviation for this data set is 5. Z-score is 1.34, and then you add your mean to it. Okay. So it's 5 times 1.34, that's 6.7 plus 250. So you add that up, that's 256.7 grams. So these are related, right? So a z-score of 1.34 would coincide with this actual weight. I don't have room for that here, but let's try normal CDF of these two values. So let's go 247 to 256.7. But now you have to use the mean and the standard deviation that corresponds to the actual weight. You still get 63.56% just like before. Okay, so if you were to use these for your limits or the z-scores, you get the same percentage under the curve. Okay, they go hand in hand. The company would like to know the weight. Okay, highlight that part. Would like to know the actual weight that would place 65% of eggs produced below this weight. How would you do this one? Well, let's make our little bell curve like this. 60, like the actual weight, where 65% of eggs are below this weight. If you want to have this in perspective, you would have to think that this is the weight that they're after. Because if you're a bit higher up the curve, that means that you have 65% below and therefore 35% above. But we don't really care about this one. We only care about this. And in this case, you would have to use inverse norm. Why inverse norm is working? Because you're not worried about the percentage. You want the actual weight. So you have to enter 0.65. This is 65%, by the way. And then enter the mean and the standard deviation of this set. And you don't have to multiply this one by 100. So you go second vars, inverse norm, 0.65, 250, and 5. Okay. And you get 251.93. What units will this get? Whatever units you had this in, grams and grams. So that's this, a weight of this amount, right, would have 65% of eggs weighing less than that. Okay. Why in the world would you want to know this? Well, in manufacturing or in industry, you would want to know, how well are we doing? Like what percentage of items we produce are in this category and whatnot. The company would like to know at what weight would 6% of the bags be heavier than it? Okay, heavier. This is the emphasis. More than. Way more. You gotta be creative with words here. You gotta maybe reword it in your head. Like, what does this mean? If you have your bell curve If 6% of bags weigh more than you, does it make sense to have the line here? You're with me? Does it make sense to have the line here? Not at all. Because there's lots more. Like this is 50, right? So you're actually way over here somewhere. This is the weight you're wondering about. It's not X bar, sorry. This is the weight you're wondering about, and you know that 6% are heavier than this weight. So what do you have to focus on? Let's erase this. You have to focus on what's to the left. So you would go 100 minus 6, which leaves you with 94%. This is what inverse norm wants. Okay? Inverse norm. You go 0.94. So you divide that by 100. Make sure you do that. And in this case, we're still at 250 and 5. So let's see here. Second vars, inverse norm, 0.94, 250, 5. That's 257.77 grams. Okay, so that a bag weighing this much would have 6% above it, but it's 94 below. That's what we. So I would say way less. Way less, way more. Okay. We're almost there, guys. Determine the z-score. What's that? The z-score of a bag that's heavier than 55% of the bags produced. And here I want to pause once. I want to make sure you understand how you should proceed with this one. I know that I will use inverse norm here, but it could be that on the test or on AC you're like, z-score, I have a formula for that, right? What's my formula for z-score? It's, is it x minus x bar over standard deviation? Okay, good. This is the formula. Can I use this formula perhaps? Well, let's see. I know the mean, right? And I know the standard deviation of this set. But do I know this? Right? I don't have the actual value. I can't do it as this. Okay. So can't use this. Can't use formula. So that's just an aside, because some students get stuck on that one. Say heavier than 55% of the bags produced. You should think, hey, this is probably inverse norm because I could figure out the percentage of bags that are less. So if 55% of bags produced are heavier than this score, where would you put it? This would be 50. I would put it slightly over to the left. And then you can say there are more here, which is 55%. And that means that this would have to be 45 over here. Always remember it's 100% altogether. So you would go 0.45, right? 45%. And what's my mean and standard deviation? I want a z-score, remember? 0, 1, okay? So z-score, I know that mean is 0, standard deviation is 1. So you can't put the 250 and the 5 because then you wouldn't be finding the z-score, you'd be finding the actual weight. Okay, so let's figure this out. It's a lot of fun, eh? I know. If you ever do this in university and you're like, oh my goodness, I remember some of these things, let me know. Okay? Let me know if it helped you. So you actually found the z-score here. Actually found the z-score. It's negative, is it? Does it make sense that this is negative? Right here in the middle, you would have 0, wouldn't you? So being over here, you're below the mean, so negative makes sense. Okay, so don't. I want you to know, it's like, am I doing this right? Um, so this is the z-score for that particular case. All right, let's keep going. Two more questions, and then I'll ask you to try. Maybe you have time to do the AC, to do the homework piece. Page 36. Determine the z-score of a bag that is lighter than 31% of the bags produced. Again, let's do this. This is the critical part. Knowing what am I given. They're asking for z-score. We know that our mean is 0 and our standard deviation is 1. That is done. Okay, that we're in z-score territory. Where would you put the line? Like, where would you cut your bell curve? If it says, like, what's the z-score that is lighter than 31% of the bags produced? Z-score of a bag that is lighter than 31% of the bags produced. I would put it here. This z-score at this point here, okay, would have 31% of the bags being lighter than that. So we use inverse norm. Why inverse norm? Because you're not asking for percentage. They're asking for the actual z-score. So we're going to go 0, 1. I can probably just copy paste this one. 0.31, and that is negative 0. That's 50. Okay, that is actually the z-score in this case. Determine the z-score of a bag weighing 259.25 grams. What would you do here? Yeah. Jay? Okay. Oh, so you're saying this should be over here? The z-score that is lighter than 31% of the bags produced. Because if you were here, maybe that's just a bad question. Like my question, not your question. If you were here, I guess if you interpret it to be here, then you would say the 31 is here, right? At which point you would be 69% lighter than the bags produced. Because this would be a z-score where 31% are heavier than the one produced. You know what I mean? I know what you're saying. It's a, and I'll try to not make it too tricky. I'll try my best to make it reasonable, but yeah, just think it through. Because here you would be, I guess here you would say the z-score where 31% are heavier than this, right? But that's not what is the case. It's asking here where the z-score where 31% are lighter than, so this is lighter, heavier. Good question. I appreciate you asking, because trust me, it's not a slam dunk. Determine the z-score of a bag weighing this. Can you use this method that we've been using? You can't, because they don't give you percentage to the right or to the left of that z-score. So you actually have to use this one. Z is x minus x bar over standard deviation. So the actual score here is 259.25 minus the average divided by 5. Make sure you do the top first or put brackets around it. So that would be 9.25 divided by 5. And that's 1.85. So the z-score is 1.85 positive. Can I just say the meaning of this? Meaning, a bag weighing 259.25 grams is 1.85 standard deviations above or below the mean. What do you think? It's positive, so you're above the mean. Above, because it's positive, the mean. And technically, you should have been able to catch that because a bag weighing 259 is heavier than the mean, right? So you're expecting the z-score to be positive. That is, I will ask you, like, tell me what the z-score tells me in that case. So if it had been negative, I would have expected you to say it means that you're 1.85 standard deviations below the mean. Okay. I'll leave you with this, and then you'll probably have a couple minutes yet to unwind and get ready for your next class. It's going to be a lot more fun than this one, right? Yeah. I know. COVID symptoms last 7 days on average, with a standard deviation of 0.5 days. If the duration of the symptoms is normally distributed, there's that, I don't know, I like to emphasize, oh yeah, that means 68, 95, 99.7, all that jazz, right? Determine the middle 80% of cases last between X number of days and X number of days. How would you do that? Well, you gotta figure, so 80% would be about this. Make the lines here. This is probably safe to say that this is 80%, correct? The middle 80%. It wants to know, the question is saying, hey, what's the first and what's that second? Like, what is the start and the end dates like that would have 80% of patients have this many days of symptoms? That's what it's asking for. So to get this one here, to get x1, okay, I'm going to use inverse norm. One second here. I have to think this one through. Maybe you help me out. I'm a little stuck. Like, what would the percentage be here? I got it. I got it. Sorry, I had a moment. Today is just not a good day for me. I got it now. Okay. It's symmetric. It's not 20. It's not 20. 80 is here, right? So if you knew 80 is all of it, then maybe, but it's not 20. How do we get this? 100. It's 100 is the whole curve, correct? Let's take away the 80. What are you left with? 20. Is it fair to split 10 and 10 over here? It's symmetric. So you're going to split that in half, and that's 10%. So 10 goes here, and 10 goes there. I almost had an embarrassing moment where I didn't know my own question, right? So this is the premise to know symmetry, right? Symmetry. We're using symmetry there. So to get x1, to get the number of days here, I will use 0.10. I'll plug that in here. And I know that my mean is 7 and my standard deviation is 0.5. I'll figure that out in a bit. We know how to do inverse norm. To get this one here, x2, I'm very curious to see if you would know what to plug in here. It's 10% and another 80%, right? It's 90% to get me to here. Like, I know that 90% are below. Either by just adding or you take the 10% away from 100. You get it either way. So this is 10 plus 80. That's 90%. So I go 0.9 here. And then that's 7, 0.5. And here we go, second distribution, 0.1, 7.5. That's 6.34. What units? Well, it's days. And then I'll copy paste and do the same thing for 0.9. That's 7.64 days. Yes, this one is a challenging one, but I decided to throw it in anyways. So it lasts between 6.34 days and 7.34 days. Voila. Okay, I just want you to try, I think 37 to 38. And I will also go 39. You have to try it. There's no other way to do it. There's no other way to do it. I wish I could. Okay. Don't do the textbook. Like, don't omit these because they didn't give you a textbook. Just do 37 to 39. Similar questions.